Welcome everyone. So we will get going. Have a lot to cover today. And quick agenda, typical welcome, research and implementation status updates. When we were on monthly calls, we did these, ZBRD update, Zcash D update. And since we're meeting every 2 weeks, like last week we skipped, and I just wanted to toss out, maybe we could just do that, if it's like a major milestone happens versus, oh, we made these announcements and things, if that's okay with everyone. We can do it however everyone would like. It's fine with me. So we'll always have this little slot in there and we can just free form it. If someone, has an update, we can do that if that works.
Sounds good.
Okay. All right. And then in terms of discussion topics for the day, we were going to talk about NU5 proposed features. We've kind of got that feature set proposed out there from ECC. There was some discussion in Discord over the version 5 transaction format and whether to include Sprout fields in the format or not. There's been some discussion on pool lifecycles, kicking that off. So we're going to talk about that. And then if we have time, we want to talk about sapling to canopy migration utility considerations. Just to kind of go ahead and start that discussion as well. And then, of course,
sapling to orchard.
I did. It's exactly what I meant. But that is also not what I put in the slide. Thank you, Dare. I do like correcting things on the fly, so I apologize for that. Okay, sapling to orchard. Okay, very good. Okay, Arborist calls briefly. It's all about protocol. So anyone interested, teams working on protocol, get together, discuss what's currently going on, things that are coming up, blockers, unresolved issues, feedback for the teams, anything along those lines.
And it's no longer monthly though.
Oh gosh, okay. I'm not gonna correct that one on the fly, but I will. I've had that slide in there since the very first one. Actually, I just copy it every month. Yes, I do need to update that. Yeah, again, the goal is to make protocol development more accessible and easier and provide more transparency outside of ECC and ZF. Anyone can participate. There's a multitude of ways to get in touch with us. We always put our contact info at the end, Deirdre and myself, kind of as a point of contact for ECC and ZF. You can reach out to any of us, use the R&D Discord, email me at this address if you'd like. So it's open to anyone that would like to present anything on Zcash protocol. We'll get you slotted in just as quick as we can. So I'm going to pop out of, let's see. Okay, we can just use this slide. I was going to pop out and go to the blog post, but so here's the proposed feature set for NU5 from ECC. It's the ones we had in the last call as well. So no difference. We put out a blog post that we have all the zips in draft mode now and merged, and also Dare's done quite a bit of work on the protocol spec. Those are all linked out of the blog post. Of course, most everyone on this call would know where to find those. zips.z.cache for all the zips, and the protocol spec is linked out of zip 224. If you don't know exactly where to find that one.
Yeah, the protocol spec is not quite complete, but I expect it to be complete by Monday, which is when the specification audit is starting.
Mm-hmm. So in terms, I mean, anything's open to discussion. Any of these, a lot of these are pretty straightforward. V5 transaction format we'll be talking about in just a moment to kind of work through what we want to include there. On the Orchard shielded protocol, or Halo, if you will, Halo on Zcash, one of the things Dodger had mentioned, just wanted to discuss, this is the first, arguably like first phase of Halo on Zcash, which does not include recursion. So down the road, whenever we implemented recursion, would that require a new shielded pool, new shielded address? So just kind of wanted to have that discussion. That was one item that I knew about ahead of time. Chatted with Strat about it a few minutes ago. So I'll just open it up to the folks that know a lot more about it than me. But
so the answer from my point of view is not necessarily. There were several reasons to do new pools in our previous upgrades. So for sapling, for Sprout to sapling, we had the BCTV 14 security flaw, and so a turnstile was absolutely necessary to mitigate any risk from that flaw. The other reason for that was that we were using a completely new shielded protocol. So Sapling used different curves, different note commitments, different addresses. Basically, it was completely new shielded protocol. And similarly for Orchard, that's also using different curves, different addresses. So it would be difficult and inefficient to not have a new shielded pool.
And it uses new curves because we need the cycle to allow the recursive proof, right?
Yeah, in future we will need the cycle. Yes, we're using the fact that Palace is an embedded curve of Vesta in a similar way to Jojub being an embedded curve of BLS 12 381G1. So we're using that already, and then we will use the cycle later. But for future upgrades, so when we add recursion, for example, we will presumably, unless something comes up that we don't know about now, we'll be using the same curves, and so we won't, and the same proof system, like more or less. It's actually easier to change because we don't need a trusted setup anymore. And so there won't be any technical necessity to have a new pool, I think.
Okay.
Now, there may end up being other reasons to have a new pool, but I wouldn't want to commit to us having a new pool at that time. It would depend on the detail.
This might be a little deep in the weeds, but can you help? I don't understand yet why the recursive proof such that we don't need the trusted setup when we're not using recursion. Is that because of the Halo 2 proof system eliminates that on its own, even if we're not recursive?
Of recursion. So,
okay.
So Halo never requires a trusted setup.
Right.
It only depends on discrete log assumptions. To a first approximation, it tends to be the pairing-based schemes that have a trusted setup, and that's because they kind of bake the circuit into the structured reference string. There are pairing-based schemes that don't use a trusted setup, but the ones Gross 16, for example.
Right. Cool.
That.
Thank you.
Okay.
So no need for a new pool, no need for a new address type.
No need for a new pool or address type as far as we know from what we know now.
It depends a bit on, so for instance, imagine that all we're doing in this recursive upgrade is adding recursion. So you have the ability to, for example, have a single proof in a block over, or using recursion to implement public aggregation. Then it's the exact same protocol, no problems. But you could also imagine a protocol upgrade where we move to a more scalable protocol, for example, using a sharded nullifier set or something else. It depends on how far that protocol moves from what the Orchard protocol is, as to at what point it would need to be considered a new protocol, or how amenable it would be for a circuit to support both the scalable Orchard protocol and the current one.
Well, I mean, we can potentially support more than one circuit. We have supported more than one circuit in the past, and Halo makes it easier because of the lack of trusted setup. But yeah, I can imagine protocol changes that would call for a new shielded pool. I mean, so Zuko thinks that we should have turnstiles much more often. I disagree. I only think that we should have turnstiles.
Yeah, I wanted to talk about that.
When we change cryptography substantially.
Mm.
Right. So that would
go ahead,
be a non-tech, like that would be a reason that is not due to a technical requirement. And I think it's an open issue. Can I describe it briefly? Like the desire behind it would be a turnstile can detect some cases of a counterfeiting attack, and detecting counterfeiting attacks is crucial for like some of the monetary properties of ZEC. And so one reason like Zuko or I like turnstiles is so that there's some assurance, although it's not perfect at all, that the monetary supply is like safe and truly rare. So like a prime example I point to is looking at the chart of the size of the sprout pool gives us some indication that the known vulnerability that occurred in Sprout was not compromised. We can't say that for sure by looking at that chart, but we know if it were compromised, it's like below some threshold, and that threshold is getting smaller and smaller by the day. And I believe that may be very valuable. It's really hard to tell though. Like if we didn't have that measurement, would people be less confident in Zcash? It's really hard to tell, but it is sort of an open issue and it's a goal. And there may be other ways to achieve a similar goal without turnstiles, but I just wanted to point out that that is one of the rationales for doing turnstiles that some of us have had.
That makes complete sense to me in the case where you've made a substantial change to the cryptography, because then you want, if there was a flaw in the old cryptography, whether we know that there's a flaw as we do in Sprout or not, and we still want to reduce the attack surface. But if you have a turnstile between two pools that are essentially the same cryptography and have the same attack surface and potential flaws, then I don't personally see the point. I don't see what you're gaining.
Well, in that case, I think the argument I would make is that detecting that there was a counterfeiting attack in a previous pool that uses the same technology as the current pool would be incredibly valuable to learn, because I think it would immediately change people's behavior if that detection happened. There's still, so the detection is not perfect, and like attackers could try to change their behavior to try to avoid it, or it might incidentally be undetected, but I still think there's value in that kind of detection.
I mean,
personally,
wouldn't an attacker, I mean, it's hard to guess what an attacker's strategy would be, but if we look at previous attacks on cryptocurrencies that have had balance violation bugs, the attackers have tended to try and cash out as soon as possible. And so in that case, you would know about it almost immediately anyway.
I suggest not trying to resolve this, because this discussion has been going on for years.
Yeah.
But
this
exactly.
has been a long-standing.
It's important to. I think it's important to revisit, especially like as Zcash is going through multiple phases and more participants are coming. It's useful to sort of revisit and touch on the points. I don't think we'll resolve them here, but I do think we need to continue having this kind of a discussion about this topic, and maybe there would be a good spot on the dev Discord for this or something.
Most of the previous debate has been within ECC, to be fair. So
a lot of it is documented on a GitHub issue that I posted in the chat, where we discussed it for Blossom.
Right, that is true. Yes.
Okay. Yeah. Before I had to jump off because isolation calls and things, I also wanted to make a note that there may be other reasons why we might want to introduce a new address format without changing protocol. For instance, the example I have to mind is if we wanted to introduce, say, we've decided not to for Orchard, but if we wanted to introduce, say, the simple version of detection keys, and just like people who want to opt into it, into using detection keys, could generate their payment addresses in such a way that supports them, that would be a new address format. But that wouldn't be a new shielded protocol, because generating addresses, it wouldn't necessarily be a new shielded protocol, but it would require circuit support for that particular kind of derivation of notes, because the way in which you generate the address affects the way in which notes that are sent to it get committed. So it would be like that would be an example of like a small change to the protocol to enable new functionality.
And shielded pools are not tied one-to-one to circuits. You can make a change to the circuit as long as it's compatible with the existing note commitments and nullifiers, that doesn't require a new shielded pool. The main thing that determines the shielded pool is the nullifier set and the commitment set.
Yeah. So like we did that for Sprout. Sprout on Grot 16 is exactly that.
Yes.
Zuko?
Another example of a new address type would be a layer 2 payment channel protocol like Zcash channels from Bolt Labs that would have a different address type, but wouldn't be a different pool.
Right.
Yeah, the consensus changes there would be, effectively in that case contained within TZDs or wherever it happens to sit. But yes, that would be a separate pool that we should be thinking about as far as concerned.
Yeah, Zcash channels is completely layer 2, so it doesn't really pose a significant balance violation risk to the L1. I mean, obviously, if there's a bug in it, then the L2 users might be defrauded of funds, but that wouldn't affect overall
amounts to a new, from a layer 1 perspective, it amounts to a new an L1 transparent pool, in the way that we have the existing Bitcoin UTXOs are a transparent pool. The TZD that defines the Zcash channels for Bolt would be a layer 1 transparent pool, whose activity is shielded in layer 2.
All right, very good. Dodger, was there anything else about Halo? I know the one thing that we discussed was, recursion, whether it required a new pool type. I see Deirdre with a hand up. Yeah. Oh, go ahead, Deirdre.
Things that, so not including recursion doesn't require a new pool, which is good. I don't quite grok, because I haven't read the whole Halo 2 book and stuff yet, like what the magnitude of the adding the recursion bit in would have. Probably not on like the code you have to write and all that sort of stuff, but like security proofs and the audits. So specifically, the spec is almost done, but Orchard as proposed does not include the recursion. There are auditors lined up for auditing the implementation, but that will not include the recursion. And I think there's work going on in the security proof to update like the existing Sapling security proof to update it for Orchard. But as far as I understand, that will also not include the recursion part. Is that correct? That's correct. Okay. So I guess I'm sort of trying to clock how big the adding the recursion part is in affecting those areas. Probably not that much in terms of like code. The things that we're doing now is probably much more code changes than actually the adding the recursion part in.
So there will be two parts to that. There's actually adding the recursion support to the proof system and its implementation. So there are obviously things that you could get wrong there. But conceptually, it's straightforward. It's just a circuit that verifies a Halo 2 proof, or more than one proof. So as far as the design goes, sort of, if you get all of the optimizations right, then it's pretty straightforward. Then you have to actually use that in a shielded protocol.
Right.
So if we take, for example, my strawman aggregation proposal, you would have to, so you need the leaf transactions, which are proving that a particular, so there are several ways to do it. Because a transaction has a variable number of actions,
Mm-hmm.
you probably need to allow for multiple leaf proofs
Okay.
representing the same transaction. So there's some complexity there. So your leaf proofs will say be equivalent to an action proof, but they will cover other parts of the transaction. Or maybe you have another type of proof that does the bits that are outside the current action proofs. So you've got to design all that, and then you've got to design a way to combine proofs to get an aggregate. So that's not just the recursion circuit by itself, because you've got to, so you end up with an aggregate being a summary of some set of transactions. So you've got to combine the summaries when you combine aggregates. And then you have the top level consensus rules that make it all make sense.
So it sounds like the adding in the recursion part will be a non-trivial security audit or protocol audit.
Yeah,
part.
It would be another. I mean, it's not quite comparable to the upgrades that we've done before, because what we're basically taking the same shielded protocol design and just implementing it in a different way. We might have to make changes to the design to make it more amenable to recursion, but hopefully not very big changes. But it would be quite a heavy engineering lift. It
Okay.
would be. You could probably only do that in an upgrade. You couldn't do very much else in the same upgrade. So similar to Orchard, really. So similar to NU5.
Right. And it probably goes without saying, but you know, irrespective of the engineering lift, we would go back through the specification audits, implementation audits, you know, development of a new security proof, having that reviewed. So it'd be that same process basically every time.
Yeah. The ideal would be that the changes involved in that would be modifications or extensions to the stuff that's going on now.
Right.
Yeah, obviously you can't predict that will be the case, but like it's the hope.
Yeah.
So
I don't think there's anything
reuse as much of what we're doing now as possible, but yes.
Yeah. I don't think there's anything that we would have to throw away. I mean, everything has been. I have been making sure that everything is designed with an eye to being able to do that in future.
Cool. I'm mostly trying to like get a sense of like, cool, is this like everything but this like one final part, but that one final part is quite novel, blah, blah, blah. Or if it's like, no, it's a solid chunk of work that will be.
It's a solid chunk of work.
All right.
The latter.
All right.
Yeah, there's a reason that that you'll have noticed while looking at the Orchard protocol that it's very similar to Sapling.
Oh yeah.
Biting off small pieces of the scalability elephant one at a time.
Okay, cool. All right. Thank you.
Nate?
Yeah, just a follow-up question though, based on what Dara said. So isn't there some chance that in the work to add recursion, it turns out that cannot be done, how do I say this? Like some of the current basis for Orchard can no longer be secure once we attempt to add recursion because of some assumption we didn't realize was present, and therefore we have to throw out or can't reuse. the
Um,
current basis of Orchard?
So it's possible that we might have to throw things out, but I think mainly for efficiency reasons rather than security, because we might find that we've used things in orchards that are not, that we can't implement efficiently in a circuit. I mean, we've tried to avoid using heavyweight hashes as far as possible. But for example, the Red Palace signatures still use Blake 2B. So that might be an example of where we would replace Blake 2B with something else like Poseidon. That wouldn't be a particularly difficult change.
It's also completely compatible with the shielded pool, so it doesn't affect anything.
Yeah, because you, those spend authorization signatures and binding signatures, they're per transaction. So it's not as if you have persistent long-term state that depends on how those signatures are done. The long-term state in the nullifier set and the commitment tree, that doesn't depend on any heavyweight hashes.
Deirdre?
Do we have any like inklings of batch math like we did for Groth 16 batch proof verification for Halo 2 to tide us over until we get the recursion deployed?
Yes, we're going to be using that. So Sean, you can probably.
Well, okay, if you want an inkling, I'll give you an inkling.
Okay.
Like the marginal cost is probably like in the 1 or 2 milliseconds, maybe even less than that. So it's really, really good.
Nice.
Verification, you mean?
Yes. Yeah.
Nice. Okay, good. Are you trying to ship that in the Halo 2 crate or?
I believe that we will have an implementation of batch, because I know Zebra's basically everything's batchy in Zebra. So we're trying to put some sort of batch API for verification out in the Orchard crate. I don't know if Zcash D will use it. We probably will want it to use it, but in any event, yeah, hopefully batch verification will be available in that.
I mean, we'll definitely use it within a transaction, right?
Well, yeah. So a single transaction is just a single. In Orchard, there's only one proof basically for all of the spends, and so in some sense, there is shared amongst how many spends and outputs and stuff there are in, or actions there are in an Orchard transaction. The marginal verification time is insignificant to the point of it's practically you can't even tell. So
right, we're able to use the batch math and the async API that we slap on top of it to batch across transactions within the block, I think. So that's what we would be, we're doing that now. We got that working, so we would be trying to do that too. And mostly I'm just concerned about like, oh, because we know that Halo 2 is slower than what Sapling is at right now, and we're waiting to get to deploy Recursion, and it sounds like it's a non-trivial amount of work to deploy Recursion, so we may not want to do it in the next network upgrade. We probably want to do it in the one after, just because we need a breather.
Well, you know, there's when we say
time.
Yeah.
So when we say add recursion to Zcash, I don't think that we know really what the next best step after. We know that what we're doing with Orchard is the right step. There's the exact next step could be a small incremental change, not just like an entire, not even necessarily public aggregation.
Right.
It could be something else. So it depends, and we're gonna have to kind of get together and figure out what is the, because we could find out while designing the next phase of what we want to do that, if we bite off a smaller chunk in the next network upgrade, kind of like what we're doing right now, that'll make the more invasive changes later more simple, give us more time to analyze the security, etc. So yeah.
Okay.
Yeah.
So that straw man aggregation is just one possible thing we could do, and I wasn't intending that to be.
Yeah. So one, for
that's what we
example,
should do.
There's a very simple, actually, change that we could make in a hypothetical orchard +1 network upgrade, which is leveraging essentially it's something that's called helped verification, where the miner that creates the block puts an advice string inside of the block, and this advice string is actually a component of how Halo-based recursion protocols work. So it's fundamental to it, and this would actually allow the verification of block to take as long as it takes to verify a single orchard proof. So it's even better than batch verification. It's constant marginal cost of verification. So it doesn't matter if there's a million orchard transactions in a block. Well, you can't fit that in a block, but it doesn't matter how many there are, it'll take the same amount to verify. Now that's a scalability improvement, and it flexes some muscles of Halo 2 and recursion while not having to actually integrate really intense recursion and recursive proofs and all that kind of stuff. So there are
that might actually be a better approach than what I suggested.
So it sounds like that is still on the drawing board, though. I was under an impression, because I don't quite fully grok the whole recursion thing. I read the Plonk paper like 2 years ago, and then like that was my last data download. It sounds like there's a lot of design to be done for the next step, and so that's why I ask about the batch math, so that we can tide Halo 2 over until we get the wins designed and deployed.
Yeah.
Because when Zebra deploys Halo 2, it'll be possibly without the batch math, because I didn't know that there was batch math. It'll be 10 to 15 times slower than what we can do with Sapling.
Are you comparing the batch Grot 16 verification with unbatched Halo?
Yes, because I didn't know there was any batch math for Halo.
Oh yeah, there's totally batching. Yep.
Okay.
And without batching, if we're comparing Grot 16 and Halo without batching on each of them, I would say that Halo on a single thread verify.
Well, we're multi-threaded.
Okay, yeah, but like just to be fair with comparisons, on a single thread, a Halo proof will verify only about 5 times slower than a Grot 16 proof.
Right. Well,
However,
I didn't know there was any batch math, but I'm just sort of like, oh, we've got really fast Sapling chain verification, and then it's like, cool, we deploy Halo, and it's like, it's not so fast.
Yeah.
When's the recursive proof coming?
I would be pretty. I suspect the marginal cost of batch verification for Halo will be much more efficient. Like, awesome. I think it'll be less field operations than doing an additional part of the Miller loop for the pairing.
Yeah,
nice.
Because you have to do one general Miller loop for each extra proof when you're batching Grot 16, and yeah, the operation that you have to do for incrementally for Halo is much cheaper.
Yeah, it's something like 5,000 or less, maybe 4,000-ish field operations, and half of those are additions. Yeah. So it's much better than in a pairing based snark like Grot 16.
Awesome. I'm seeing batch in Halo 2 crate, so I will go read more of the crate math. Thank you.
All right, very good. Hey, Paco had a really good question in the chat. It says, can recursion be used to make note management trivial and therefore make wallets faster? My understanding is yes. No.
I mean, changing the design of the protocol will allow us to make note, like we might change the protocol in such a way that takes into account how note management should work, and note management might actually be a central design concern of how to design like a new shielded protocol or a scalable shielded protocol. So I think, but that's orthogonal to recursion. Recursion's more
Okay.
about making the blocks and the transactions and the reducing the bandwidth and increasing the performance of verification of stuff.
The thing that recursion would help with for light clients specifically is speed of which they can start like from scratch. So like right now you have to pick a particular height, we checkpoint at a particular block, and then whatever your mobile client had internally, you start from them, and then you have to keep downloading from Lightwallet D. Recursion or a recursively verified chain would allow you to just download the latest recursive proof and have just verify that locally, and then know that the entire chain up to that point, up to that point from the point at which we started doing recursion, so is fine.
Yeah. So I was slightly confused by something you said, Sean. You said that the miner could include an advice string in a block that would allow you to verify all the proofs in constant time. I'm confused because doesn't the verifier still have to look at all of the proofs?
Yeah, I said constant marginal time.
Yeah. So it's still linear to all the size of the number of proofs?
Right. So it's O number of proofs.
I might be lying a little bit, like, but it's only like a single group. Like adding you have to add the elements of the proof to a multi-X, but it's that's not a significant contribution of the multi-X. The multi-X was mostly thousands of group elements. It involves thousands of group elements that are in the SRS or not the URS. And so so in batch verification, you're trying to check a bunch of things. You're trying to check that a bunch of group elements are correct, and you can do that probabilistically with the scalars. And actually, GOT16 does something like that in batch verification with using this sort of accumulation-based verification, or this helped verification of this advice string. You don't need to do that probabilistic arithmetic over the scalars per proof per transaction. You just have to you don't have to do that. Basically, you have to open up a
So the proof size is O log n for second size n. So it's number of proofs times log n, right? You still got to read the proofs.
Can you say what your claim was again, or what your question?
So, assuming you have the advice string, the verification time is proportional to the total size of the proofs.
Yeah. So hence why it was a little bit of a lie. But what I'm referring to, amortizing away.
You said O number of proofs, and you meant O log n times number of proofs. But that's fine because log n you can almost treat as a constant.
Okay. All right. Other questions related to Halo before we move on? Good. Okay. All right. Just quickly, the Ncc Specification Audit kicks off on Monday. So it's kind of just we pin that timeline down a little bit since the last call. And we're still working to get a second vendor, audit vendor, to do kind of a parallel set of audits, more focused on the cryptography. But that's kind of in flight. But the timeline that we've gotten from them is consistent with what we have up here. So no concerns from that perspective. Okay, and then V5 transaction format and sprout fields. So I'm going to pop out, and there is, let's see if I can get this to move out of my way. There we go. Proposal to remove, yeah. So there's a PR out there, Zcash zips 453. And there's also been, some discussion in Discord as well. So who would like to kick us off on that? I know there's Strad, you had mentioned, Sean, go ahead. Yeah.
Yeah, well,
start with you.
I mean, I don't really have any strong opinions on this. I just wanted to kind of put across the fact that from our perspective, it doesn't really matter if we do this or not. We hate Sprout just as much as probably the Zcash Foundation does, and anyone else that works on the protocol. So
We don't hate it.
yeah, I guess we don't hate it. It's okay, but it's getting a little old. So
Yeah, long in the tooth.
we're happy to. This is such a minor change that's like, we do it or not doesn't even affect our day, doesn't affect our timeline, doesn't affect. And if there's any objections from anyone, then I think that we would feel like maybe we shouldn't do it. But if there are no objections, then I think we're happy to do it, to be honest.
So the only thing that I wanted to raise was that there's an interaction with how we do the migration.
Right.
So if we remove these fields, then we wouldn't be able to migrate directly from Sprout to Orchard. We'd still be able to migrate via Sapling. So it kind of interacts with what we were going to discuss next, which is the migration behavior. But I don't particularly see anything wrong with not being able to directly migrate from Sprout to Orchard. I don't think it's necessary.
I mean, right now, the only wallet that supports Sprout is Zcash and wallets that wrap Zcash, like ZecWallet, full node. So the set of people who have Sprout funds is the set of people who already have the migration tool from Sprout to Sapling. And if they are, and if they want to maintain the same kind of privacy as other people who are migrating from Sprout out of Sprout, they would probably want to just use the same tool into Sapling rather than switching to migrate from Sprout to Orchard, would be my assumption.
Mm-hmm.
Yeah, I think that's reasonable.
Yeah.
And Strad, you mentioned one caveat the other day, like if there was an issue found somewhere and we had to disable transaction format version 4, then we would effectively be disabling Sprout at the same time if we don't have these fields in V5.
That's more of a meta issue. So like I'm okay with like doing this for Sprout in this particular case. But it was more about the meta issue of how we treat pull life cycles and pulls going forward. I conceptually like the idea of deploy a transaction format that doesn't include the old stuff, and then when we get rid of that transaction format, we turn it off. But yeah, the concern there is if we do that, we're basically committing ourselves to turning off whenever the old one gets turned off for whatever reason it gets turned off, which may not be a conscious decision to deprecate the old pull.
Yeah, I haven't noticed this proposal until just now, and I would be concerned about that very issue because it would couple the policy about pool life cycles with the transaction format, and that might bind our hands. Like, what if in the future we want to introduce a change to Sprout functionality, like a penalty fee, which might be controversial to say, but or something else on the way to removing it, then does that mean we're going to have to create a new transaction format that's a descendant of 4 but not of 5, or would we loop Sprout back into version 6? It just starts to make me uneasy.
Yeah, I don't think that this concern I'm about to voice is directly impacted by this, but the point that you just alluded to is along the same lines. I think we haven't yet agreed on a policy with regards to dormant or potentially abandoned funds. So there has been ideas kicked around in the past of just after a certain amount of time just saying, right, that's it, those funds are gonna be destroyed. And I'm personally not a huge fan of that because I think it would damage Zcash's reputation as a store of value. There's my terrible idea for creating a centralized faucet, which is a terrible idea. But until someone comes up with a better one, that issue is going to remain open, right? But
no,
I think
I know.
But and I know that there's been some talk of Sprout on Halo, which sounds like a really good solution. But I think until such time as we as a community agree what our approach is going to be, then I think we need to avoid painting ourselves into a corner that would force us down a particular path.
These are pretty significant arguments from my perspective.
Yeah. It is worth noting, however, the Nathan's comment about like, do we need to reintroduce it if we have to? Well, we can. So one of the nice benefits about V5 onwards, due to the other thing we're doing in U5, is that the transaction format isn't consensus critical. It's just how we ship data around the network now. So the way it should be. So we can just like leave it out of V5, and then if it turns out we want it again, if we have to get rid of V4, we can bring it back in a V6.
Can you explain that a little more? Can you explain why V5 on with Orchard is not consensus critical versus V4? What's happening?
So the reason for that is that the thing that makes a transaction format consensus critical, well, that makes a transaction consensus critical is how it gets bound into consensus. Okay. That is by the transaction ID, which binds the effects of the transaction. In U5, that is now a Merkle tree over the parts of a transaction, not the transaction format. So the consensus critical part of removing Sprout from V5 would be we would not include Sprout components in the TXID calculation for V5 transactions. That bit would be the consensus critical change. The V5 format is irrelevant. So the real proposed thing here would be if you have a V5 transaction, it is impossible for it to contain Sprout because the TXID digest does not include a Sprout component. But a V6, you could just add a Sprout component back in and you've got Sprout back. So, and we know we're going to at least need a V6 because we're considering TZEs for Bolt, and that requires a transaction format change and additions to bind that TZD data into the TXID and so on. So we know we're going to have at least one more TXID transaction format indicator.
Yeah. So that means that we can make this decision either way for V5, and we're not bound at all by it in V6.
Yeah, if that's the case, which it sounds like it is, then we can bring Sprout back in the transaction version if we really need to. Right? Yep. Yeah, then I would err on the side of let's remove it with the knowledge that if we really need it back, we can bring it back because of the non-malleable transaction IDs now.
Yeah. The restriction then would be if we had a problem with V4 and we had to cut V4 before the next network upgrade, there would be a patch of time where Sprout wouldn't be useful. I personally think the chance of that occurring is quite low.
Same.
Yeah, I mean, the only thing I can think of is if there was a bug in zip 143, but it's so similar to 243 that I don't see it. Sorry, if there's a bug in 243 that there wasn't in 244, I mean.
Okay, Nate.
Sorry. Yeah, so an alternative I'm curious about that appeals to me for some reason would be make V5 support everything any wallet might need to do, and also phase out V4. I don't know if it's too early to phase out V4, but what can anyone comment on, like the comparison to that?
I mean, it's not a big complexity hit to keep Sprout in V5 because I mean you have to be able to support those fields for as long as you support V4 transactions. So and if you wanted to, you could even do a soft forking change that would require end join split to be 0, and that would effectively remove the sprout fields without actually technically removing them.
Yeah. My thinking on that though is, as far as like removing v4, I'm reluctant to remove v4 in the same really in the same upgrade we introduce v5 or going forward similarly. But in this case, in part because like the change to TXID calculation is quite a large lift compared to what some of the ecosystem has had to do in recent upgrades. If we think of like, you know, hardware wallet providers and so on, who have to, you know, the Zcash transparent apps will need to know how to create and derive v5 TXIDs. This is partly why we're not proposing changing the way that v4 transaction IDs are computed, which has the effect that like v4 will still be malleable, but it means that people can, we don't have to have those parts of the ecosystem deploy v5 transactions prior to the network upgrade. They need to be aware that the network upgrade has happened because they still need to have the consensus branch ID in order to create v4 transactions correctly. And so as usual, they shouldn't just be shipping that in, they should be checking that like for v4, they've done the necessary changes they have. And there are like zip 216, for example, changes that shouldn't be relevant to them. They might want to consider. But in my mind, there's a like doing it as a two-phase, like turn one on and then turn the other off, just gives them a bit more time to do it. They're going to be incentivized to do so because other people on the network, like there's nothing stopping someone sending me on my hardware wallet a transaction that was v5 to my on hardware wallet address because they're both on there. So people will be incentivized to add v5 support. It just gives them a bit more time to do so than having to get everything in place prior to the upgrade, which they would have to do, and in fact did have to do for when we deployed Sapling.
But isn't that kind of independent of whether the sprout fields are included? Because then it's unlikely that they're going to be creating transactions with sprout components. If they're still doing that, then they're probably still creating v4 transactions.
No, they won't be creating sprout pieces. I was just I wasn't talking about the removal of sprout.
Why does it matter? In that case, why does it matter that we're removing the sprout fields from v5?
Well, it would matter if we were getting rid of v4. There'd be a motivation to keep the sprout fields in v5, because otherwise we wouldn't have anything with sprout.
Right. Yeah, I see what you mean.
Okay.
Yeah.
Time check. So what I'd suggest is we can keep the conversation going async in Discord R&D, and we can, you know, we can obviously put it on the agenda to continue talking about next time if we feel like we need to. I do want to move forward, Nate.
Yeah, but before we move on, I actually think that's quite a strong argument that if we wanted to remove v4 or deprecate v4 sooner rather than later, potentially sooner than we're removing sprout, then that's a good reason to keep sprout in v5.
I'm a little bit concerned about, so I totally agree that we should not switch from v4 to only v5, but I am concerned about it being a little bit of pulling teeth to phase out v4. So, but I guess we'll get to that sooner or later.
Okay.
All right, Nate, you want to take it away? I can drive the slides for you if you'd like.
Yeah, thanks. How much time should I spend
on
this?
We have about 20 minutes. And
okay.
I mean, we have another topic, but it's not urgent. Like we could pick it up next call as well. Okay. So take your time. This is pretty important and a lot of interest in it.
This is, okay, so all of these slides are fairly high level because I think there's sort of an impetus, or a lot of people want to, for example, let's remove Sprout and figure out how to do that quickly. And that's sort of the focus, and that makes sense. But this is sort of higher level of this overview. And the thinking is, let's have like a consistent approach to retiring any pool generally for a few reasons. And then if we can get that, then let's start applying it to pools. So general needs, why would we need this? We want to be able to deprecate old tech generally. And that helps us reduce like the number and type of addresses, and which can cause confusion for users over time. And I already put a question mark here because I know this piece is maybe something we could do a different way, or something a goal we would sacrifice, but that would be when we can phase out old pools, if we can account for the money supply coming out of the pool, we can be certain that after it's removed, there was no counterfeiting attack.
So that's definitely a way to achieve that goal.
Yeah.
I just want to be clear that it's not necessarily the only way to do it.
Yep. Yeah, true. But I think it is the way I thought it was the way we have been using, like the way we're currently using for Sprout. And so if there's other ways, we should figure out how to switch to those explicitly. And so this whole idea is, let's define this concept of pool life cycles. Every kind of pool has a life cycle. And there's some really important assumptions at the bottom of this slide. So one is that all funds are in a pool, which is a little bit of a shift in terminology, because I think by convention, we always talk about shielded pools only, but in this framework, I thought we should try to be general and make sure that includes UTXOs, so it includes the transparent pool. And then later we can figure out if there's important differences between transparent and shielded that need to come back into play.
And TZs may complicate this slightly as well.
Yes.
So.
Yep. And there could be new kinds of pools in the future that aren't like UTXO based or other weird stuff. But maybe we can still have a consistent conceptual framework. And I would hope, so we had requests from inside ECC and outside, hey, let's make sure we're deprecating stuff as we're rolling out Orchard. And I totally feel that, I love that, but we basically didn't get to it in time. So what I'm hoping is we can get something in place for NU6, because I really do not want to drag our feet on this, and I want to get something moving, because once we sort of make this transition, which is a big transition conceptually for users, that yes, we are going to deprecate pools, it can really sort of start the ball rolling, I'm hoping. So next slide. And feel free to interrupt or ask as I go. I'm just going to talk through the slide. So some history, like in the first design that we launched with Sprout, there was only transparent and Sprout. So there was already sort of, there was no possibility of shielded pool to different shielded pool transfers. So there was already sort of this innate accounting for the balance of the Sprout pool. And there's really no other way to do it with that design. But then later, when we were adding Sapling, we did discuss and think about, can we do like shielded migrations? And we decided not to for multiple reasons, but some would be engineering constraints, like that it's too complicated or it wouldn't have good performance or whatever. And then some would be some more of the product or strategic layer where we're thinking, well, actually, we want to be able to account for the balances of the different pools in case something goes wrong. And we started talking about turnstiles, so that word started floating around. Then later, we discovered a critical vulnerability in Sprout. And so suddenly,
historical
like
note.
Yeah, there's a link here. You should read about it. It was an exciting period of our lives.
Can I interrupt?
Yeah.
This is Zuko. Tiny little historical note that the concept of turnstile enforcement was discussed before Sprout, before Zcash launch.
Right.
So
yep.
maybe it was discussed.
Didn't we used to call it like New Year's or Chinese New Year?
Oh
or
yeah,
something?
it was going to be called Chinese New Year
Yeah,
at one point.
Huh. Okay.
which is a
I
totally
thought
weird
that was a
name,
little
but
bit appropriative, but yeah.
if the only thing I know about the Chinese New Year is it's really hard to predict when it is. So I don't know. For me. So right. So in that era, though, it's like, okay, we've had these discussions, but now let's like make sure we have a consensus rule. So at the time, there was actually no consensus rule that would prevent pool balances from going negative. And so we introduced a rule that would just make it illegal for any block that you can't have a block accepted if it does that, which is a very weird consensus rule because it ensures that the condition that detects this terrible thing cannot be part of consensus. And you kind of, I would rather make sure it would be a part of consensus. But what this rule does have an effect of is that if you, an effect it has is that funds that are in a pool where a counterfeiting vulnerability occurs can be destroyed by this rule so that whoever holds those funds can no longer exit the pool. And the total balance of all pools from sort of outside that pool still adds up to the expected issuance rate. So that's a somewhat weird property. It doesn't really help individual users, but it sort of arguably helps the overall system. And when we approached Orchard, we wanted to repeat the same approach for a couple of reasons. One was because we still have the motivation to detect counterfeiting and we still have the engineering constraints of complexity. But also another part is that strategically for Orchard, we wanted to keep the design as similar to Sapling in every way that we could, just so we weren't biting off too much. So that's a little bit of history. Next slide.
Tior had actually asked for this one, so I thought I would just
yeah.
toss that in there. Yeah.
Yeah, this is great. So this is a chart that shows how much ZEC is in each of the 2 existing shielded pools. So Sapling is the lighter color that's newer, and it's the one on top. And so you can see the darker one, Sprout, the older pool. When Sapling was released, you see that there was kind of a big migration, but then there was a period like through most of 2019 where it leveled off a lot. And then recently, a bunch has exited. And so if that graph like went below 0, that would mean there was a counterfeiting attack detected. If it hits 0 perfectly, we can just turn off Sprout and it would be, you know, the perfect event. It would be so simple and we wouldn't have all these tricky issues to deal with. But assuming there's no,
because I personally have lost Stripe funds. So
yeah, okay, so it won't happen. Thanks, Dara. So yeah, the problem is if there is no counterfeiting, but people have lost wallet keys, then those funds are bricked and they're just going to sit in that pool forever. And that's we're going to run into that in some later slides. So next. So there's a bunch of open design issues. So the first one is this, I call it universality, but in the first slide, I was saying, hey, let's have the same framework for every pool. And I also like every pool has a finite time span, even if we don't know what it is. We agree and communicate to everyone that it is finite so that they know they can't depend on it sticking around forever, which is not an assumption all users may have. And it is contrary, for example, to Bitcoin's design philosophy from what I understand. So like, how do we answer this question? Does every pool have a finite time span? If we say yes, then there's something about consistency as a concept for all users. And that helps us also ensure we can phase out all old tech because we can treat everything consistently. But it precludes some use cases. So these are the only two I know of, but there might be others. So one would be indefinite cold storage, where you've buried your secret phrase on a desert island, and you never know when you're going to dig it up. And there's a map with an X. The other one is where you may sign a transaction. This one's a little bit surprising sometimes, but I definitely see like Bitcoin devs having referred to this use case where somebody has like a signed transaction that was made ages ago sitting somewhere, and someday they have some agreement with someone that they're going to submit that transaction to the network. And there's actually a case.
We already do not support this use case because of consensus branch IDs.
Yeah, I was going to say
those transactions will be invalidated on the next network upgrade.
That is a great point, but I don't know if all Zcash users know that, because we always say Zcash is like Bitcoin, but it has great privacy. Oh yeah, but by the way, there's these other really important differences that you may not, if you expect it to be like a Bitcoin, you may be in trouble. So I think we got to do a better job of identifying that thing. For example, that slipped my mind when I was writing the slide. So anyway, these are potential surprises for users that are very nasty surprises. The no side means we could support indefinite cold storage. And I put a maybe there because it's hard to promise anything can last forever. It's kind of a weird promise, but it would be less surprising to users because it would be more like Bitcoin or more like what you would, I mean, I think it's somewhat natural. If you have some data that's valuable, to not realize it may have a limited lifetime. But then we would have to maintain old technology for old transaction functionality for a long time or forever. And that includes like security risks and operational costs and development complexity and user conceptual complexity and a bunch of other things.
So there's a bit of nuance here because what you really have to maintain is just part of that shielded protocol. So for Sprout, for example, you have a note commitment for each note and another file, but you can regenerate the note commitment tree potentially using a different hash function. So what you would, if you did say Sprout on Halo, what you would do probably is you still compute the note commitments in the same way and the nullifiers in the same way, but the note commitment tree gets replaced with something using Synsomnia or Poseidon or whatever. So it would kind of become a hybrid of the new and old crypto. It would still be quite inefficient, but not as inefficient as you would naively think.
Right. Yeah, that's a little bit different than just leaving on a really old design that sits there forever.
But on the other hand, that's a lot of development work, and you have to ask whether it's actually worth it.
Right. So one issue is if you do this really sophisticated thing to support an ancient pool, but no one, it's very rare that anyone issues a transaction for that. I kind of would bet, despite the best attempts at design, something would go wrong anyway if it's such a rare event. But anyway, yeah. So open design issue. Next.
I mean, I think we could do it securely. I just would prefer not to have to.
Right. So cold storage, should we try to do something about cold storage? This is exactly what Dara was discussing. So idea one, maybe there's some way to move out of old pools that make some trade-offs, but the burden on the current protocol is sort of minimized some. Idea 2 is sort of similar, but it's sort of like, let's make an explicit cold storage protocol that's future-proofed, and then so it would be like an exception to the pool lifecycle rule. Like, this is the one pool that's permanent, but we try to make it so simple that nothing can go wrong or something. It's just a brainstorm. And then there's this really important risk down here that Zuko mentioned to me, but if we're clear, so here's a thing that I was worried about and why I started talking about pool life cycles instead of deprecate sprout, because it feels like deprecating sprout is the easy, obvious next step from like an engineering standpoint. But if users see that and there's ambiguity, or there's not clarity about say t-adders having a limited lifespan, they might get this message, even though it's implicit, oh, all of the shielded pools keep getting phased out and changing, and that seems risky, so I'm just going to use the t-adders for cold storage. So I feel like if we're gonna to manage this risk, that's why I like universality. That's why I like saying every form of storage will be phased out, so you can't depend on any of them, to sort of start working on those expectations. And it's really hard. This sort of expectation management is really hard because we don't know if we can reach all users. Users have strong privacy, and we don't know what their expectations are or what they're currently doing. Ooh, I see it. I heard a ding and I see Zuko's hand suddenly. Zuko.
That was an accidental ding, but it worked. I just wanted to say that's not necessarily bad. You said this is a risk that users could use the shield or the transparent pool as their long-term storage and bury their spending keys under concrete and all that. Maybe that would be good. But I think it's really good for you to point out that it's going to go one way or the other. Either users are going to start treating all pools as transient, or they're going to start treating some pools as more permanent than others. And what we've done so far, including our current work to deprecate Sprout, is pushing them to treat the T pool as permanent.
Probably.
That's just a fact. I don't know if that's good or bad, but that's just a fact.
I absolutely think that we should set the expectation that eventually the T pool is going to go away.
Well, let me just comment. You said set the expectation. I don't think anything we say in this call or blog posts or Twitter or our user docs or the source code or anything else is going to set that expectation. I think the fact that we've deprecated, or that we already have and are continuing to deprecate the Sprout pool, but we have not deprecated the T pool, is setting the expectation, and nothing we say is going to set any other expectation.
Is there evidence of
the only
that?
way you can set the expectation is start penalizing people for using the T pool or something, which I don't know if that's a good idea, but I'm just saying words we say are not going to change this. People are getting their expectations set by the fact that the Sprout pool stopped working and the T pool hasn't.
I want to remove the T pool.
What's that?
Just put it out there.
Are they getting, is that actually happening, or is that speculative?
I believe, well, it was mostly, I was saying it just based on my opinions about human nature, but that's a really great question.
Like, I don't doubt that might happen, but I was wondering if you had seen like that was already happening in the community.
That's an excellent question. And I have heard a couple of private comments or maybe public comments. I'm struggling to remember if I have them written down or whatever, but I have heard people saying things to that effect, that they store their Zcash in the transparent pool for longevity. Or
here's a controversial take. Here's a hot take. I say that the value add of Zcash over Bitcoin or a lot of other cryptocurrencies is in the Z to Z, is in the moving of money. Yes, you can have a bunch of money in your wallet and the balance is private, but if you just have a bunch of money sitting in your wallet privately forever, you're losing out on the ton of the value of what Zcash offers. So if people are using, I don't want to encourage more T-adder usage, but if they were using T-adder usage for long-term storage, and if Z to Z transaction usage, actual sending of money privately continue to grow in like the way we would like to help encourage as the value add of Zcash. I'm not that bothered by that. Yeah.
One little comment, that was an awesome hot take. I love it. And this is a total tangent, but you just made an assumption or an assertion about the belief you have that I believe the opposite. So I just wanted to call it out so you're aware for the future reference that I think that, well, I think I might be the opposite, which is just the aside you said that the value comes from privacy and privacy comes from transactions. I currently half think, yes, the value comes from privacy, but privacy comes from storage, not from transactions. Total tangent.
It's more complicated than that. Okay, can I give my take then?
Yeah.
Okay, so in the long term, T addresses are unsustainable for scaling reasons because we don't know how to scale T addresses. We do know how to scale, perhaps not even the Orchard protocol, but some future shielded protocol will be scalable. And the main reason for that is that the Bitcoin scripting language is just completely intractable for circuits. You cannot implement the Bitcoin protocol in a circuit. So we will have to either make sure that T address involved transactions are a small fraction of the total transactions, and in fact bounded by some constant, so that they're not even scaling at the same rate as the total transactions. Or we accept that Zcash doesn't scale at all, or we move everything to shielded.
I like that last one.
That's a really good point.
Excellent.
So I just want to reiterate and then go back to Nathan's slides that I think we're currently communicating effectively to everyone something that none of us intend to communicate, which is that the T pool is permanent and all the shielded pools are transient. I don't think that's what we meant. And so, but back to Nathan's slides, I think it's lovely to make that decision explicit. Like, what is our intention going forward? And then how can we communicate it to people?
One comment on, I'll jump in, I'll let you go, Jared. Sorry. On Nathan's specific proposal, which is that saying that all pools, including shielded and transparent, are transient, that they are all expected to eventually go away or get rotated out in some way. I don't necessarily think I agree with that, because yes, we want to be able to make changes to Zcash and add new pools if they are needed, or we have new optimizations, or, you know, a new advancement proofs or something like that, like for a reason. But I would be very loath to deprecate the latest, like say Orchard and the recursive proofs that we deploy in a future network upgrade are like the bee's knees and nothing really beats it, and it's awesome and secure, and like we're very happy with it, and it scales real well, like indefinitely, and we have no good reason to deprecate Orchard and like Orchard plus.
That's a good point.
I would be loath to just be like, well, we just said that they're all transient, so we just gotta like migrate away from Orchard because
we're going to have to migrate away at some point, because we're going to run out of at some point we're going to run out of the U32 space for block.
That's easy. That's easy to fix. No, that's trivial to fix.
Yeah, but you can
aren't you concerned about quantum computers, Deirdre?
We're gonna run
Well,
about
exactly.
Yeah,
I was gonna say that too.
Oh, we're gonna run out of
Deirdre,
yeah, running out of
Deirdre.
You're
quantum.
You're a very good point there, Zuko. Actually, I had not even been thinking about the quantum adversary.
It's the first time I caught you not thinking about the quantum adversary.
Yeah.
Yeah. But I guess the under the levity of the point I was making there is that the fact that we are comfortable with the protocol and we are happy for it to be fine and continue on, does not necessarily mean that we want to box ourselves to never move away from it.
Sure.
Right.
Because it may be comfortable for like a 20-year cycle rather than a 2-year cycle. But that doesn't mean that in 20 years, we're not going to want to migrate away. So I would still be comfortable with that saying like, it is a finite duration, but it's not like a fixed finite duration. It's just like people shouldn't expect they can come back in 100 years and expect it to be fine.
Yeah,
or
I think
even 3
there's
years.
there's multiple options. There's like, we guarantee that this isn't eternal, but we don't know how long its lifetime will be. We guarantee we're going to kill this in X years, which reminds me of Ethereum's like proof of work bomb, or what, the difficulty bomb in Ethereum, which by the way, I think they keep postponing. But
it's
the
never
idea
actually
there,
worked, right? Like it's generating very interesting data, and the data is that it's never once actually not been procrastinated.
yeah. Then there's another one, which is just ambiguity, like we don't say anything, which is where we're at today. And then there's another one where we like guarantee something's permanent. So I meant by saying every pool has a limited, a bounded lifetime, didn't mean necessarily we guarantee we know the bounds up front. Instead, it's just always leaving the door open in expectations to say we might decide to close this pool in the future because there's a newer tech. That was sort of my thinking.
Sure.
Yeah.
I think there's a case for strategic ambiguity, and the word ambiguity is kind of casting a value judgment and saying that's bad, but it's not necessarily. On the other hand, I want to argue for saying that we can remove any pool with sufficient notice. So we haven't yet talked about what that notice should be.
Right.
I think we should decide on a specific period, like say a year.
Yeah, I think from a minimal
number of venues.
Yeah, from a minimum viable product point of view, from a security point of view, we just have to have some expectation that people can stick to. So whether they know where to go to find out, or whether they know how long to check, or even initially the requirement here was just they know that Orchard inside this pool isn't going to be permanent. There is impermanence with the pool with respect to the coin. I think that's like the minimum.
Yeah.
Okay. So time check, we're out of time. So I think Nate was about halfway through these slides. So can
we just zip to the end, because there's next steps and I have a call to action and I don't want to lose the opportunity.
Sure.
Yep.
Sorry.
I'll put it back up.
Okay.
Let's see. Let me get on the right slide.
Oh, wait. Can you just skip through them one by one, just in case there's something I just can't let go of? Cold storage. Okay. Next one.
That's what we were on. Yeah.
Turnstiles. We already talked about that before this presentation. I have similar issues. Next one, incentives. Let's skip that, but it's fun to look at if you care about figuring out this. So, okay. Last one is, here's where to go to find info. We can post the slide somewhere so people can find the links. Last one is next steps. One more slide.
Yep. So that's 452 that's mentioned here. So that's a great place for discussion. Yep.
Yep. And then the last one was, hey, let's do something. Let's do something for NU6. And here's the challenge, like, what does that mean? Like, which pools is that going to apply to? So we've talked a lot about Sprout, but it could also be that we haven't figured out how to remove Sprout, but we want to move Sapling along or something like that. I don't know, but it's just a request. Can we not let this slide past NU6, which means can we see if we can agree on a next step or a framework, I don't know, by like sometime in May or something, so we have time to spec it out. That's the request. Thanks.
Very good. Okay. Actually, we're dead on the money time-wise, so excellent work, Nate. Okay, so that's it. We can continue, we can spend a little more time on this next time. So we move through those last few slides pretty quick, or whatever we need to
so
do.
there is something we need to decide relatively soon whether we're going to include the sprout fields in the NU5, the version 5 transaction format. So the auditors, they can audit both possibilities. So that works, but I think when's the deadline for making that decision? I think the deadline is probably end of March.
Why don't we?
Don't know.
Why don't we do a very quick vote? Does anybody object to keeping the sprout fields in transaction version 5?
Object to keeping them in?
Yeah.
You frame that without negatives.
I would rather they were not
Who votes to omit the sprout fields?
Well, hang on. There are 3 possibilities here. There is strongly prefer to omit, strongly prefer to keep, or no preference.
Well, the reason I'm saying if anybody objects, then we finish the call and we take the discussion to the Discord. But otherwise, we could make the decision here. So that's why I'm asking if anybody objects to keeping the sprout fields in version 5.
Anyone object?
To keeping them?
No,
Yeah.
to removing them.
Oh.
Dodger stays.
No, sorry.
No.
Okay, I'm so confused.
No.
I understand what Dodger is saying.
And maybe this is an indication that we need to take it offline. But I'm asking if anybody objects to keeping the sprout fields in transaction version 5.
I do not object.
I think we should not keep the sprout fields in transaction version 5.
That's an objection, so we move this offline.
That's an objection.
Yeah, that's an objection. We move it offline.
So close.
That's fine. No, it's fine. It's absolutely fine.
I saw him about to speak, and I almost muted him in time. But I'm sorry.
No,
Okay, all right.
it's important. It's an important decision.
Yeah.
So yeah, it's good.
Yeah.
Okay. All right. Very good. All right. Everyone have a good rest of the day and a good weekend. We'll catch up async in Discord.
Cool.
It was lovely. Thanks, everyone.
Bye.
Thanks,
Yeah.
everyone.
Bye.
Ciao for now.